Okay, let's work first by graphing each inequality and making sure that it's in slope-intercept form to start with. So we have to get the 2x on the other side. And you're left with what? Y is greater than or equal to a negative 2x plus 2. Remember, what's the only thing you have to be careful when you have an inequality and you're working with your variables? What do you have to be careful of? Watch when you multiply or divide both sides by a negative number, and then you have to change your sign. But we're good, aren't we? We're okay. So now I'm just going to graph this inequality just like it were an equation. What do I do first? Graph the y-intercept, which will be 0, 2. Very good. And then what do I do? Okay, I go down to the right one because my slope is a negative 2 over 1. I go up to the left one. Okay, so I get several of my points plotted. Now, will this be a solid line or a dotted line? Okay, a solid line. Okay, we've done that one. And that is y is greater than or equal to negative 2x plus 2. What do I still need to do now? I have to do my shading. Okay, so what do I have to do? Put a tester in. What can I use for my tester? I can use 0, 0. Okay, so let's plug in. Is 0 greater than or equal to negative 2 times 0 plus 2? Well, this is 0. So is 0 greater than or equal to 2? No. So this is not on the true right side. So what do I want shaded? Everything on this side. Okay, everybody agree with that? All right, now let's go to then the second inequality. Whoa. Let's get that off there. What do I have to solve for here? Solve for y, so subtract 2x again. And what do you end up with? Okay, y is less than negative 2x plus 4. Great. Now I'm ready to graph it. Okay, what do I do first? Turn and tell your partner. Okay, do the y-intercept, 0, 4. Good. Okay, then what do I do? Get my slope, which my next point from my slope, which I go up to over 1, up to over 1, or down to over 1, down to over 1, down to over 1. What do you notice about this line? Okay, they're going to be parallel. It's a dotted line. Very good. Now, let's see which side we're going to shade in this case. So what do you want to use for your tester? Okay, let's use 0, 0 again. 0 is less than negative 2 times 0 plus 4. Is 0 less than 4? Okay, so it is true. Now you have to be careful. When I'm shading this one in, I'm shading let's do a light blue. I'm shading everything from this dotted line and to the left, correct? Now, it's kind of hard for you to do this because you have only pencils, and it's really hard to see your shading, the differences. So when you're graphing inequalities and you're doing a system, because remember a system is 2, and that's basically what this is. We have just graphed a system of inequalities. You will then only shade in what they both have, okay, where they overlap. So where do they overlap? Okay, just between the two lines. Now, we'll include this line. Yes, it'll include the line. Will it include this line? No, but it includes everything in between. Okay, so now I'm going to have to erase some. if I can very carefully. And then I want to erase this part. So when you all do it, what I would do is I would do like diagonal lines and the opposite diagonal. So in other words, when you're shading in one side, you would shade in, okay, this was the first one, and then this was your second one, and maybe I'd go in the other direction. And where they overlap, or where you see kind of like the little X's, or you can get colored pencils from me. Okay, if you'd rather use colored pencils, I'm good with that too. Because the only thing then that you would have left would be the shaded part in the middle. So you've just found the solution to a system of linear inequalities. So that's our goal today, is to learn how to solve systems of linear inequalities. And here are the two basic steps. You're going to graph each inequality and then shade. And remember, how do you decide which side you shade? By a tester. Very good, by a tester point. Then the solution is the overlapping shaded regions. All right, so let's try one. The first step is to graph them, but what form do they need to be in? Okay, are both of these in the nice form? Okay, they are. Good. So we're ready to start now. Let's graph the first one. I'm going to graph it in red. Okay, so what do I do first? Y-intercept, okay, 0, 1. And then I go down 2, over 1, down 2, over 1, down 2, over 1, and so forth. Or I can go up 2 to the left 1. And is it going to be solid or dotted line? Okay, it's going to be a dotted line. Okay, now what do I need to do? I have to shade. Don't forget your shading. Graph each inequality and shade. Can I do 0, 0 as a tester? I can. I can do 0, 0 as a tester. Let's do that. Is 0 greater than negative 2 times 0 plus 1? Is 0 greater than 1? Nope. Okay, so we don't want this side shaded. We want the opposite side. Okay, so if you want to take your pencil, and what I will do, I'll do it kind of like why you could do it possibly. Let's use your pen, and I'll just say that, okay, this side is shaded. Just kind of make little marks. And eventually what you'll want to, you can probably do, after you do several of these and get the hang of it, you might even put just a dot on this side. Okay, saying, hey, you know what, I know this side of this inequality is shaded, and a dot down here. Okay, now we're going to go to graph the second one. Your y-intercept is 3, 0, 3, and then I go up 1, over 1, up 1, over 1. Okay, I'll give you a moment to get that one graphed. Solid line or dotted line? It's a solid line this time. Good. It's really important that you use your straight edges, your rulers to draw these lines. Okay, and then what's the next step? I have to decide which side I'm going to shade. Now remember, this is our line. This is our inequality line right here. So can I do 0, 0 as a tester? Yes, I can. So is 0 less than or equal to 0 plus 3? Is 0 less than or equal to 3? It is, so then I want this side shaded. Or you might have to say, okay, I have a dot on this side and this side of my line. Okay, then what will be the solution of this system? where the red and the blue, where my red and blue overlap. Can you see the section where they overlap? And it kind of makes into the V of your two inequalities. So I'm going to highlight this yellow. Okay, but if you want to leave yours just as where they overlap, that is fine. And what I sometimes do is I have students then, oops, that's not yellow, have them then shade just lightly with their pencil the part that overlaps. You don't want to circle, you want to do shading. Okay, but you can just shade then the part that overlaps. Like you've got your lines drawn and then just shade what part overlaps. And then that's your solution. So if I'm looking at it, I'll know that the part that you have shaded the darkest will be your solution. Okay, I want you to try one now on your own. You have two inequalities. Y is less than or equal to 3. And then the second one is x plus y is greater than or equal to 1. Go ahead and finish this system of inequalities. And when you think you have a solution, we'll have you check with your partner, and then we'll go over it together. Okay, the first equation or inequality is y is less than or equal to 3. Where do you plot that? Is it a horizontal line or a vertical line? Horizontal, and it's going to cross the y-axis at 3. So we know that it will go across solid line or dotted line. Solid line. Going across approximately right there. Okay, which way am I going to shade? And I'll put a 0, 0 in there. Is 0 less than or equal to 3? Is 0 less than or equal to 3? Yes, okay, so it would be shading going down. Okay, so this is y is less than or equal to 3. Okay, let's then plot your second inequality. What do I have to get by itself first? The y. So you have y is greater than or equal to, do I have to switch the sign or anything? Nope, negative x plus 1. Okay, your y-intercept is 1. Then I go down 1, over 1. Make sure you look at it and say, okay, my slope is negative, so it should be going in a negative direction. Now remember, the solution to a system of equations is 1 point, but here we're looking at inequalities. You have shading, so it could be any point that's where? Your solution is going to be any point that's located where? Where they overlap, or what I'm going to call the darkened shaded area. Okay, does yours look like that? Solid line, is that correct? Okay, and now we got to do a tester. Let's do 0, 0. Is 0 greater than or equal to a negative 0, which is 0, plus 1? Is 0 greater than or equal to 1? No, so then my shading should go this way, because the 0, 0 didn't work for this one. Okay, so where do they overlap? Okay, right in here. Now you do want to go ahead and shade all the way up into that little, right into the point. And then all the way over. Okay, and this is what you should have shaded. So any ordered pair that's either on either one of these lines or in that shaded area would make both of them true. So that's your solution. So somebody pick a point. Pick a point. Somebody give me a point. Okay, 3, 1, 2, 3, 2. Okay, let's see. Let's put it in here. Y is 2. Is 2 less than or equal to 3? Yes, because remember your x, you're taking it times 0 and get canceled out. Okay, plug it into this one then. I have 3 plus 2. Is that greater than or equal to 1? Yes. Okay, so any ordered pair in the shaded area will make it true. Any other questions on solving linear systems of inequalities? All right, now let's take a look at an actual word problem. Kishi makes $7 an hour working at the grocery store and $10 an hour delivering newspapers. She cannot work more than 20 hours per week. Graph two inequalities that Kishi can use to determine how many hours she needs to work at each job if she wants to earn at least $90 per week. What do you think we need to pick out first in order to do our inequalities? Okay, you need to look at your two totals. Her first job is the grocery store. She makes $7 an hour working at the grocery store. Okay, and then she's going to deliver newspapers, getting $10 an hour getting newspapers. It says she cannot work more than 20 hours per week. So when we total up our hours, it has to be under $20. Now, how do I get my hours? First, let's set up our variables. Okay, let's let X equals the hours she working at the grocery store. And Y is going to be the hours she works at the newspapers, delivering newspapers. Okay, so when I'm figuring out my total hours, it'll be X plus Y. It has to be less than. Can she work 20 hours? Yeah, because it says no more work. She cannot work more than 20 hours, but she could do 20. So it's less than or equal to 20. All right, we have 1 now. What's another total that's given in the problem? Okay, that says she wants to earn at least $90 per week. So her money's going to be at least 90, greater than or equal to $90. Now, how do you figure how much money she's taken in? At the grocery store, and X represents the number of hours, it would be 7X plus 10Y is greater than or equal to $90. Okay, now you have your two inequalities set up. What do we need to do next? Okay, let's graph them. So we need to set them both equal to Y. Y is less than or equal to negative X plus 20. Okay, what about this one? I subtract 7X, and I get 10Y is greater than or equal to negative 7X plus 90. I have to divide everything by 10, and I'm going to get Y is greater than or equal to a negative 7/10 X plus 9 after I divide everything by 10. Okay, now we need to set up our grid. Now, because this is a real-life problem, are we going to deal with negative numbers? Probably not. So we can look at our origin being right here on our axis. Okay, how do you want to set up your y-axis? Well, we need to go up to 20. So how do we need to stay on top? 2, 4, 6, 8, 10, 12, 14, 18, 20. Maybe I'll count by ones. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19, 20. It would fit exactly. So we count them by ones. Okay, this would be 10. Okay, and this is 15. So our y-intercept is 20 up here, and then I go down 1 over 1. That would be a solid line or a dotted line. Okay, it'll be a solid line. Okay, and this one represents the amount of hours she can work. Now, it has to be less than 20. So let's see which side will be shaded. Let's put in a tester of 0, 0. Is 0 less than 20? It is. Okay, so we're going to have this part shaded. All right, now let's take a look at our other inequality. What's your y-intercept? I'll plot this one red. Okay, 9, 5, 6, 7, 8, 9. And I go down 7 over 10. 7 over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and these are labeled as ones. Remember, these axes are representing the jobs. The X represents the hours at the grocery store. And then this one's going to represent the hours at the newspaper. Okay, so then when we have plotted our lines, we can connect them. Solid line or dotted line? Okay, it looks like a solid line. And let's check our shading. So let's put a 0 in here. Is 0 greater than or equal to 9? No, it isn't. So this part will not be shaded. It will be shaded this side of my line. So where did they overlap? They overlap in the middle. So all of this, any of this ordered pair in this area, including the lines, if we picked an ordered pair on the lines or in this shaded area, it would satisfy her requirements to work less than 20 hours and make more than or at least $90 per week. So, can you give me an ordered pair that would work? Can you give me an ordered pair that would work? Okay, she could work 10 hours at the grocery store and 5 hours at the newspaper. So you could have 10, 5 would work. Can somebody give me another one? What about 9, 11? Would that work? Yes, it would work. She would probably max out her hours, but 9 and 11 would work. All right, any questions on how to solve a problem solving of linear systems of inequalities?